But I'm super excited to get the chance to talk to you and talk about time series database and all this world of telemetry. So it's even a little bit more challenging because it's actually very complementary to what Raul was talking about. And hopefully I will show you because I really think it's complementary. And I can see how some people will see that as a contradictions of what Raul was explaining, but I really hope I gave you the good idea. Time series database is really this topic that I've seen a lot of people now using it in the network industry, and most of them usually there is this haha moment, like when people see that, they don't imagine not using it. And I still see a lot of people that don't even know that exists, but I was really feeling we have to go and talk more about it, and it's one of those topics I really hope as an industry we will start to talk more about it. And another thing is, when I was at Juniper, I was talking about it, and I realized that I was talking about it from a vendor's point of view, and I was missing some things that it was another haha moment when I went on the customer side and I realized that, when you consume the data, it's different when you generate it, and there's different things. So again, I'm hoping to share some of that with you. So what is Roblox? You might never heard of it. Roblox is a gaming and social platform for kids. We're pretty much building everything to enable other people to build their games, monetize their games. It's been very successful. There's over 90 million active players every month. We have 2 million active developers. From an infrastructure point of view, Chicago is a very special place for us. It's actually our main site. We have most of our infrastructure here. So really love Chicago. So in terms of agenda, first, I'd like to spend some time talking about why we need to learn those new time series database, why it's important. I understand that as a network engineer, there's a lot of pressure those days to learn new things. There's a lot of pressures about learning automations, learning software. I personally feel those technologies should be probably at the top of the list, or really in the top 3 on things you need to learn because they're really important. And I'll spend time talking about where is the industry today, as I see it. What are the pain points, where are we coming from? Then we'll look a little bit deeper at time series database specifically. And I hope that then you will have an idea, how that fits in the picture. And then I'll give you an idea of what we built at Roblox using those technology and all of that. So why do you need to learn that? And I found this quote online that say, data is the new oil. And I think it really relates to what Raul was presenting. But the idea is that if you're able to find it, you will need to extract it, you will need to refine it, and then you will be able to monetize it. And it's a very generic statement, but when you look at those different steps, that actually makes a lot of sense. And all the questions, for example, we were talking with Raul, were about, how it is important to refine, to have the right contextual information, and all of those things I'm going to talk about. So I don't think we really have a find issue. Actually, this slide is very similar to Raul's. We have a lot of data in the network. We have the hardware data, we have the software, the OS data, the protocols, the traffic. We have too much data, and every time, every day, there's new protocols and system. Our issue is really we don't have the right tools to make sense of the data. And again, that's the point that was made earlier. And machine learning is definitely going to be one of those tools. And hopefully you can see how time series databases will complement that. And I truly believe that a machine learning system will do better on top of those modern time series databases than they are on top of your traditional monitoring solution. So really complementary. Now, if you look at extract and refine, I personally value one aspect of it is how fast are you able to extract new data from your network? I don't know about you, but I have the feeling that every month, every quarter, there's somebody that comes and asks me visibility into something on the network I never thought about. And then the challenge becomes, how fast can I get those new information from the network, extract it, refine it, and make it available for other people to use? And I have this crazy example that was really specific to us, but one morning it became critical that I give people visibility on the utilizations of our DHCP Relay pool on all our top of rack. Turned out that our pool are pretty small, and they were trying to build hundreds of servers, and they had big congestions on those pools, and the business was really hurting because they didn't have visibility. So I was able to use those tools and basically create a parser, extract, refine, tag with all the right informations, and put it and create a dashboard so that the server guys could actually check and see if the servers were stuck because the pools were full or because they had an issue with their build system. And basically, we enable the business to be able to move faster. So it's just one example, my example. But I'm sure everybody has these kind of examples where they come up with things you haven't thought about. And that leads me to what does mean monetization for the network? And of course, for most of it doesn't mean generating money. But I'm sure we all have this challenge, like reduce the time to root cause, how long it takes us to prove that it's not the network, or sometimes how long it took to prove that it was the network. But really about bringing more visibility, helping visibility, and all those tools. There's a lot of part about enabling visualizations and alerting and all these kind of things. And what I found is that, and I explain later, like because of the tool we have right now, we haven't really taken ownership of this visualization part. But with those new generation of tools, and I have a couple of examples, we're able to build extremely powerful dashboard. And what I found is that the better person to build those dashboards is the network architect, is the person that has the better knowledge about the platform, because you won't ask a third-party guy to build the best dashboard for your networks, to show the best metrics, to understand how it works. We have to take ownership of that. And to be able to take ownership of that, we need to understand what are those tools, what capability they provide, and how we can use them. A lot of the things I'm going to talk about today might seem outside of your space. You're like, hey, I'm not a DevOps guy. I'm not going to install those databases. I'm not going to manage them. Yes, you won't. Maybe some of you will. But what's super important is I think you understand how to use them, how those become requirements for you to build the best dashboards, to enable other people to understand what is the network doing, or to help you troubleshoot your own system. And for that, you might not have to manage all the database, but we will need to learn some new skills. And that's hopefully what I'm going to explain and help you to understand today. I have this dashboard I found, a good example is someday I was turning up a lot of rack switches, and I had really a need to have more visibility into a lot of different data. It's just an example of how you can build a dashboard that has a lot of different data. And here we see on the right, there's actually, I'm tracking the evolutions over time of a group of BGP sessions. And you can see when there is orange in the middle and yellow, it actually reflects that those sessions were flapping. And I was able to correlate that with the amount of traffic overall on all my switches. And it's not presented here, but I also had like the light levels. And having all those information, being able to have a single page that you can go and explore data is immensely useful to understand the state of the network, move faster, and troubleshoot. So where are we today? And I'm not taking a lot of risk making the statement that most of us are probably in these situations where we have an all-in-one network monitoring solution that is pulling information from the network using SNMP and most likely collecting some logs. And I think there's a lot of issue here, but maybe not where you expect. So all of those tools, they're actually sharing usually one component, which is something called RD tool. I don't know if you heard about it, but it's at the heart of Observium, Cacti, MRTG, OpenNMS, Nagios. All those solutions, they use that to store and the data and generate the graph. If you've seen those query graph, that means you're using RD tool. And RD tool was a fantastic solution when it got introduced in '99, but it has a lot of issues. And the first issue is that it is not a database. It doesn't have a query engine, meaning it actually have a deep correlation between how you store and how you visualize. And it doesn't enable you to really dig into the data and do anything. Basically, whoever define and the system, how it gets collected, define how it's going to get used. Very little flexibility on what you can do with those data. And I don't know if you realize also the big issue is the downsampling happening. Like, I don't know if you're worried about, or you understand why we have always those multiple graphs side by side. And it's usually because it is how RD works by having different actually files where I store the first hour or the first day with the real like 5-minute granularity. And as soon as you move to the next day, you're actually already doing downsampling and reducing the value and the accuracy of the data that you have. And that's a big issue because it's super inefficient and you're losing a lot of precious information where nowadays, and that's going to extend later, there's so much better solution out there that really can do better with the data, and that's what I'm going to introduce today. As an industry, I feel like we've been talking a lot about we want to kill SNMP. We want to kill SNMP, we want to do telemetry streaming. It's been a really hot topic in the industry. I worked at Juniper, I was one of the first involved in that, I talked a lot about it. And looking back now, I feel we may not have talked about the right topic in this space. Like, personally, I feel we've been talking about the streaming, but we haven't really spent time explaining how we're going to consume those data. And also looking back, telemetry streaming is a great advancement in the industry. Don't get me wrong, it has a space. But I feel like as a vendor, I was trying to push it everywhere, where it might not have a place everywhere. Like there are some use cases that requires telemetry streaming. No question asked. If you're building an SDN controller, you need that. If you want to build Curity self-driving car, you need that. But as Raul was mentioning, in a lot of cases, we don't need, sub-second, sub-10 seconds accuracy. And actually, having telemetry streaming might not be such a strong requirement. So we need, I think, to step back and understand where the solutions fit the best and where they might not be the best solutions. And talk more about how we're going to consume those data and what are the important things to make sure that we can use them in the right way. There's all these discussions about should we do pull, should we do push. I personally think it's a waste of time to talk about that. Actually, when you look at what other industries are doing, they are doing both, and they are doing it at the very high scales. Like, there is no technology challenge nowadays to do pull or push. So again, we should, in my opinion, not spend too much time talking about that. So what are the other industry doing? Because I personally always look toward the server guys, the DevOps guys, to understand what are the technology they are doing, because usually there are things for us to learn. So if we look on the server side, how are the monitoring system works nowadays? And usually it starts with an agent, something that is sitting on every server that will be in charge of collecting the data. Then it will send that to a database, and then it will have another system that will be in charge of visualizations and the learning. So the first pattern we're seeing is there is a disaggregation, where for us, everything is coming from an all-in-one solution. Here we have disaggregation that let us choose the different components, that let us scale them differently and evolve. There's way more flexibility. It is more scalable. And another thing we're seeing is there is a specialization in terms of storage and visualization based on the type of data. And it's really important because we have very different type of data. For example, we have metrics data, which usually are also time series, relies to numeric value that evolve over time. So for us in the network, we have a lot of that. It's like all the counters, anywhere from CPU to counter on the interfaces. And then there are log data, events that are more text-based, unpredictable, can happen at any time. And we also have all the data that fits in either of them that we'll call structured data, like the routing table and all those information. So what we're seeing is we have now different type of pipeline and visualization system for all of the data. It's not ideal, but the value that we get from those specialized solutions are really providing so much value compared to what we have that right now that's where we are. And I think we will have another layer on top of that, like what Raul was presenting, like for example, an aggregated solution that will get data from all those different pipelines and that will provide even higher level correlations and all of that. So what I'm going to talk about today is more about the metrics, and I won't cover the other pipeline, but keep in mind that there's also some interesting space and things happening on the other side. Just here some example of open source project. There is a lot of open source. It's a very active ecosystem around all the different layers, the collectors and the agents and the alerting. You cannot go wrong with any of that, honestly. And there's a lot of documentation out there, and it's a very, very interesting space. One that I'd like to highlight specifically is an agent called Telegraph that I found to be a really good one to start with because it is where you get the data. It is the one that you will use to refine the data, and it can plug into most of the databases out there. So it's a really good place to start, very powerful, and I've seen a lot of people using it with a lot of success in the network industry. If you don't like building everything on your own and do it yourself, it's totally fine. There's also some cloud-based solution out there, And basically, they just replace the database and the visualization and alerting with a solution that you can use out of the box, but you will still need the agent. That's why I'm saying investing in the agent is something that anyway will take you really far, and you don't really have to spend too much time picking the right database. Pick anyone, get started, learn, and you can always switch later or use one of those cloud solutions. It's totally fine as well. So now, there's all those great tools. How can we use that and bring that back into the network industry? So I'm going to try to give you some example. I'll just pick a couple of vendors and situation, but try to think, more than that. Like the first approach, if you have a Linux-based NOS, like Cumulus or Arista, it's fairly easy. You just take those agents, you can pretty much install them out of the box, and you will get a lot of information. You will get a lot of NOS type information, the one you get from Linux. You might not get all the routing information out of the box, but it's a really good place to start. Now, if you have more legacy system that just support SNMP, you cannot install system on the box, then you can use agent running outside on another server like Telegraph that will be able to use SNMP to connect to those systems and send back the information. I've seen some people had a lot of success with that. There's a blog from Lindsay Hill, I don't know if you're familiar, that has a really good tutorials on how to get started with that, which is the exact system. I put at the end of my slides link to a set of blogs and tools, probably not enough, but I put what I could find in the time I had to help you get started. So at the end of the presentation, feel free to check that. You can also, and that's what we decided to do at Roblox, use your own collectors written in any type of language that will use APIs available on the device to collect the information. So it collects through netconf, or collects through eAPIs if you're using Arista, or any other form of APIs that your vendor can provide. That's an absolutely viable solution. And then if you have some device that I will call telemetry streaming enabled, you still try to understand that. And there are a set of collectors that usually the vendors are providing that are more like specialized to each of their platform. I'm not aware of really a vendor agnostic, awesome collector that you can use in this space yet, but as all the vendors now are implementing these GNMI formats, I really hope we will get a more vendor neutral and awesome collector in this space. But look at your vendor, there's probably a solution that they provide out there that you can use to get started. So what are those time series database? And maybe let's look a little bit deeper on that and then try to explain some key points that I think are important for us to understand. So first, there's really something that happened 5-6 years ago when the server guy started into their automation journey. They realized that they didn't have the right tool as well. And so they started building all those new type of database optimized for time series that will give them this flexibility and the visibility that they needed and that we need today. And there's multiple solutions out there, but they all have the same principle that they decorrelate, which is kind of classic for database, but for us on the telemetry it's new. Like they decorrelate the storage and the visualization. The idea is that you store the data and then you have a super powerful query engine that will let you decide how you want to visualize that. And I'm going to give you some example. So in all those, and every database has its own, unfortunately, like query language, but you can find some shared components. I'm using here a database called Prometheus as an example because I found that their query language is one of the easier to get started with. But really, don't get caught on the technology. The concepts are very similar everywhere. And the idea is that usually you will have what we call a measurement. That will be what is the type of data that I'm collecting. Here there will be, for example, I want to count the interface bytes, output bytes on a given interface. And then you have a set of tags or label. And that's a critical part because that defines the context that how the data has been collected. So if you're talking about an interface counters, the minimum context that you need to provide is what is the name of the device and what is the name of the interface. And then we have the value, which is a counters. So if I collect all those counters and I just visualize them, I get that. I get straight lines, pretty in interesting lines, because the counters that I collect are just absolute numbers that grow over time, so that's how they look like. We're not used to that, but that's technically what RD is collecting as well. And if you look at one of them, it's just a growing counters over time. Now, what's interesting with those databases, and I have the query on the top, is that you can do operation on those data on the fly. And you can say, for example, I don't want this data. I want the rate of this data over a 5-minute period. And I would like to multiply that by 8 because I don't want the bytes, I actually want the bits. And then the database will return you now the right information that you're looking for. And that's why, as a network engineer, like the people that are going to build those dashboards will need to know this query language, because that's how you define how you want to use that. And again, other people before you and me have done that, and they had a lot of success. So it is absolutely, something we can take on. If you don't want a specific interface, but if you want, for example, a view of the traffic on all your interface on a specific device, you can do that as well. You can do, I'd like to get the rate of every interface, and then I'd like to get the sum of all the interface of this specific device in this specific dimension. And again, the database very easily will now return a single time series for each device that will give you those information. And you can do even many things. You can, divide, for example, by the speed of the interface. If you're more interested about the percentage of utilization than you're interested about the bytes per second, there's many things you can do. I'm not going to say it's comparable to what Raul was talking, but those databases even provide like linear regression, some form of light machine learning to have some, predictions of how the traffic is going to look like in a few hours. There are some very interesting operations and math and comparisons you can do on all those data on the fly and define that and dive into those data. Now, there's one thing that is super important, and I think that's something that we don't talk enough, and I wasn't talking enough about it when I was at a vendor, is that what you can do with this data depend on the number and the type of tags and label that you have in those data when you insert that into the database. So, and it's super important, like think about it. If you don't have the role of the interface, if you don't have the role of the device, if you don't have all of that, you will be limited in the query that you're going to be able to do and you're going to be able to make on those data. So it's very important that as we provide our requirements to the people that will build the tool, that we explain that we want to have all those data in there. And because we're able to put it in there, we will make whoever is consuming those data even better. Like, for example, somebody was mentioning the use case where what happens if I upgrade my software? What things we are doing at Roblox is we put the version of the software in which the running on the device when we collect the data in those meta tags. So for example, when we consume that, a machine learning system could easily understand that that's something that changed over time, and then it will be able to account for that. And the context of your data really depends on your environment. There are some of us that are pretty generic, but there are some of them that will be, about your internal customer name, your internal naming system and conversion system, and you need to take ownership of that if you want to be able to use that. So, for example, here I have a device that is connected to a large number of providers, transit, transport, IXs. I have many different interfaces for each of them, but what I was interested was to have an overall traffic per providers, irrespectively of how many interfaces I have for each of them. That's the kind of query that are super easy to run with those systems. And if tomorrow I realize that I don't want that, but I want actually the providers by site or whatever, again, super easy to do. So that was my 5-minute introduction to the time series database, but hopefully now you understand that, why it's important to learn those queries and why when you build those requirements, it's important that we have the right, the right question and all of that. So what have we been building at Roblox? And as I mentioned, I think I already gave you some hint. Our network is mostly composed of Juniper, so we decided to go with the netconf approach. And we're pulling all the information over netconf. We decided to build our own collector because we couldn't find a collector that was giving us the ability to insert those tags on the fly the way we wanted it. We're using a database called Prometheus, Grafana for the visualization, and I'll talk about it a bit later, but we also use and build something for alerting. Because we found that there's also some lack in this space. So why we build our collectors, I mentioned because we wanted to have the ability to insert our tags. We wanted to have the ability to have more dynamic inventory. It's in GitHub if you're interested. I will not call that, like it's still, I will say, in beta stage. It supports Junos and F5 today. If I was redoing it today, I will probably do it very differently. But if you're interested and you're using Juniper, I think it's a good place to get started. I often get the question, why netconf? Why not? Are you not using telemetry streaming? And back to my point earlier about how fast can I extract new information from the network. If you think this way, what's most important is what is the interface that will give me access to the biggest volume of information from the device. And I will argue that the interface that gives you the most information today is the CLI. Then on Juniper, you probably get 99% of that from netconf. Then you get probably a little less of that from SNMP. And at the end, you get even less than that from streaming telemetry. So when I got started, for me, it was more important to pick an interface that will be able to give me access to all of that. Like my DHCP Relay pool information, I'm pretty sure I will not get that from telemetry streaming. And I'm fairly confident it might not be available in SNMP either. So for us, that was the right tool. And we're collecting over, I think, 1 or 2 minutes in most cases, and there's no issue. Like, we can absolutely do that. In few places in the future, we will look at introducing telemetry streaming, but it's more opportunistic for really the type of data that we need faster than that. But for most data, there's, for us, in our mind, no need for that. So, and also why we build those collectors and some of the system is because we wanted to hook everything into our source of truth. I think the next talk is about source of truth, so hopefully, if you're not familiar, that will give you some idea. But the idea is there's a lot of information that are not available on the device itself. There's a lot of information about the role of the device, about the context, or that might be hard to just get from just looking at the configuration. So for us, having a tool that integrates with our inventory system, with all those systems that is able to bring all those custom contextual informations and insert them before we actually put in the database was super, super important. So again, that's where if you remind the discussions about you need to find, extract, refine, and monetize. The refine is really important. The refine is about what are the contextual data that I need to insert in my data before they get into the database. And that will just enable you to do more with your data, and that will enable the system to do better things with your data. So there are contextual information that are per device. There are some that are per interfaces or per, I don't know, BGP sessions, whatever you are collecting, but we need to learn think this way. We also build, just to cause a system for learning. I feel that will make a talk on its own, but so we also build an alerting system because all those solutions will generate individual alerts. Now we wanted something that will actually understand, like, for example, when a link goes down, I usually get 4 alerts, one from each device on each side about the interface going down, and then I get that for the BGP session going down. But technically, if one of those devices is actually in maintenance mode, I would like all those 4 alerts to be silenced. So we build these solutions to be able to understand that, hook back into our source of truth, and be able to understand the topology of the system and reaggregate those 4 alerts, for example, in this case, into a single one, and silences if we know that one of the devices is not expected to be up and all of that. So again, there's a link. It's a project on GitHub if you're interested. But I think it's another things we noticed that the industry doesn't yet provide those tools. So that's all for me. I think we have a little bit of time for question, and I really hope I gave you this, the motivation to start investigating and learning about those time series database.